Hi everyone, hope you all are doing well. Stay home, stay safe, protect yourself and your family too. Thanks for watching my videos and thanks for subscribing. If you are not subscribed yet, please subscribe to my channel and encourage me. And if you like the video, please click on the like button and share it with your friends. If you want to give any suggestions or if you need any clarification related to the topic, please let me know in the comment box. I will give you reply definitely. And don't skip the video in the middle of the session. It is very fantastic topic that we are going to see today. Periodic classification of elements. That is included in 10th class, but it is also required for the students who want to write Olympiad exams. Okay, and IIT Foundation courses. So it is very important to learn about this periodic classification of elements. And I will upload this topic in 3 parts, and the first part that we are going to see today. The remaining 2 parts will include Mendeleev's and modern periodic table. Okay, without wasting time, we will move into the topic. Okay, what is there around us? Everything around us is nothing but matter. You know, basic units of matter, fundamental particles of matter. Maybe atoms or molecules. Atoms or molecules. Atoms may or may not have independent existence. Molecules have independent existence. At the same time, you have learned another thing, element. What do you mean by an element? Element consists of atoms of only one kind. It is a pure substance. Element is a pure substance consisting of only one type of atoms. Only one type of atoms. So, you know elements. And some elements, 1 to 30 elements or some elements are there. So far, how many elements were discovered? So far, 118 elements were discovered. And in that, 98 elements were natural. 98 elements were natural. Remaining are synthetic elements. As the time progresses, so many new elements are discovered. And there are lot of elements and so many properties are there. It is very difficult to understand if they are kept unorganized. Okay, so there is need arises to group all the elements into respective categories based on their similarities. Because so many elements are there, so many properties are there, but the need arises to make it easy to understand their properties and to make them easy to learn also. To know their properties in order to make it easy. Due to the efforts of so many scientists, whatever the periodic table that is available for us, that is modern periodic table, came after the lot of efforts of different scientists. And who are those scientists? What are their efforts that we are going to see now? Okay. Nowadays, for some of the students, not for all, for some of the students, it is difficult to learn the things what are there in the textbook even. But they have sorted out all the elements and they have seen the similarities and they have kept it one place. And how much effort they did. Once think about it. How much effort they have given to make this periodic table. At least we should honor them and we have to learn. To honor them, you have to learn the periodic table. It is the way to honor them. I think so. If you also think so, You can also learn periodic table. Okay, let us move into how it is evolved. Initially, elements, not only elements, whenever you take some materials, always based on the similarity we will classify. Yes or no? For example, you went to a grocery shop or a supermarket. You went to a grocery shop or a supermarket. There what you will find? You want something in your mind. You want to purchase some chocolates. Okay. Then all the articles or all the materials which are available in the grocery shop or supermarket are kept here and there. How can you identify the item what you want? How can you identify that? Is it easy to identify if they are kept here and there without any proper classification? There arises classification based on the similarities. Eatables at one place, in eatables, chips at one place, biscuits at one place, chocolates at one place. Like that, based on the similarity, they in the grocery shop or supermarket, they are sorting out. Just like that, to make it easy to know what are those elements, this periodic classification of elements evolved over a period of time. The first basis is whatever the known element that were there previously. First they were classified as metals and non-metals. Simply they classified as metals and non-metals. Long back, first classification you can say based on their properties, metals and non-metals. That is the first classification related to the development of periodic table. Later on, so many efforts are given by different scientists, but the most notable effort afterwards is Dobereiner's. The most notable effort later on is Dobereiner. And Dobereiner classified the elements and arranged the elements in the increasing order of their atomic masses. What he did? He arranged the elements in the increasing order of their atomic masses, and he made those elements into groups of 3. He made the elements in the group of 3. What is the basis? How you have to remember what is Dobereiner contribution to the development of the periodic table? What is his contribution? His contribution is he arranged for the first time based on the atomic masses. Increasing atomic masses he arranged. That is the first contribution and notable contribution. And he arranged the elements in the group of 3. In the group of 3. That's why his model is Dobereiner triads. Triads 3. Like that, 3 triads he has arranged from the elements known at that time. Okay, and he also proposed that if we take any triad, whatever he proposed, 3 triads he has arranged. If we take 3 triads, he has arranged in the increasing order of atomic masses. If we take the middle element, atomic mass, it is approximately close to the average of other 2 elements, and that means first and third element. It is the average of first and third element. The second element atomic mass is the average of first and third element in his triad. Arithmetic mean of first and third element will give approximate value of mass number of the middle element. What are dobereiner triads and what is their atomic masses we will see. Lithium, sodium, potassium. This is one triad. Then chlorine, bromine, iodine. It is another triad. Okay. Lithium, sodium and potassium is one triad, and chlorine, bromine, iodine is another triad. Calcium, strontium, barium. These are the three triads. These are the three triads given by dobereiner triads. What he proposed, you need to understand what is the contribution of dobereiner's. He has given triads and how he arranged the elements in the increasing order of atomic masses. Order of atomic masses. That is the first contribution. Increasing order of atomic masses. And he also given one point that if we want to calculate the mass of this, it is the arithmetic mean of first and third element. It will give approximate value. Whatever the mass is there, it will be the approximate average of these two. Are you getting? Approximate average of, this is 7, you know. This is 23. This is 39. This is 39. If you calculate 39 plus 7 by 2, 46 by 2, that is 23. Like that, if you calculate for calcium, strontium and barium, the same result you will get. Chlorine, bromine and iodine also. If you calculate the average of these two elements, you will get approximate mass of this. Approximately. The mass of that, if we compare, it is very close to that. In this case, it is exactly same. But if we calculate this, it will come approximately. Okay. You have understood the point and what is the basis. Increasing order of atomic masses, and he has arranged the elements in the triads. And the average mass of first and third element, if we calculate, and it will give the value which is approximately close to the mass of this one. That is the point he has given. But he was unable to arrange all the elements that were known at that time. What are the demerits if we want to say? He was unable to arrange the elements whatever are available at that time. Unable to arrange whatever were available at that time. First best contribution you can say, because he has arranged the elements in the increasing order of their atomic masses, and 3 triads are there. Triads itself 3. He arranged 9 elements in 3 triads. If we calculate the average mass of first and third element, it will be almost or approximately the same as that of the mass of the middle element. Okay, but he could not succeeded because he was unable to arrange all the elements what were known at that time. That is his drawback. Okay, but he laid some foundation by taking this order of atomic masses. Later on the scientists have developed the periodic classification based on these points. So his contribution is recognized. That is the reason why. Okay, even though he was not successful in classifying all the elements, whatever the property that he considered here, atomic mass, it laid the foundation for the future scientists. So his contribution is recognized. Okay, next one, dobereiner triads over. Now, Newlands law of octaves. Newlands law of octaves. With Dobereiner's inspiration, you can say, he also arranged the elements. Newland also arranged the elements in the increasing order of their atomic masses. Okay, he has arranged the elements in the increasing order of their atomic masses. At the time of his work or practice, there were 56 elements. Okay, he arranged all the elements. He arranged all the known elements up to that time in the increasing order of their atomic masses. Okay, increasing, what is his basis? His basis also increasing order of atomic masses. After he arranged that, he has observed one point. He has observed one point. What is that point? Means there is recurrence in the properties, because recurrence in the sense there is similarity in the property of the element. If we consider the first element, every eighth element is having the similar property with that of the first. Every eighth element is having the similar property as that of the first element. He has arranged what are the elements available at that time in the increasing order of atomic masses. And he has observed one point, that every eighth element is exhibiting the similar property as that of the first element. Recurrence in the property. Okay, similarity is there between the properties, and that's why he called it as octave. Just like if you take musical notes, sa, re, ga, ma, pa, da, ni. Okay, these are 8 notes, right? 8 notes of a musical. Again, sa will repeat, no need of this sa. Sa, re, ga, ma, pa, da, ni. Again, sa will come. Just like that, the property of every eighth element is similar to that of the first element. He has arranged the elements in the increasing order, and he has found the point that the property of every eighth element is similar to that of the first element. Okay, and as they resembles just like the musical notes, 8 notes, sa, re, ga, ma, pa, da. So he named this as Newlands octaves. the every eighth element is resembling the property of the first element. He named it as newlands octave. Whatever he arranged the elements in this order, he arranged every eighth element is exhibiting similar property with that of the first element. Okay. Shall we see what are the elements that are mentioned by him? Hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, calcium, chromium, titanium, manganese and iron. And for your understanding, you have to know one more point. Whatever he arranged the elements, this recurrence of the similarity in the properties, is observed up to calcium. And after that, every eighth element is not exhibiting the similar property as that of the first element. Only up to calcium, this Newland's law of octaves is applicable. Okay. This is the one of the drawback. What is the basis for his arrangement of elements in the order of in the increasing order of atomic masses? While he arranged that one, he has found that every eighth element is exhibiting the similar property as that of the first element. But it is only applicable up to calcium. Later on, only part of it I have written. He has arranged some more elements. Only part of it, to make you understand, part of it I have written. Still some more elements he has arranged. And after calcium, if we take every eighth element, it is not exhibiting the similar property as that of the first element. That is the drawback, first drawback. What we can write? What is the first drawback we can write? Only up to calcium. That means the elements having low atomic masses are only satisfying this law of octaves. Only up to calcium. Okay. Then later on elements, if we take eighth element, the properties are not similar. And next one, dissimilar atoms. After this, what he did here, cobalt and nickel he kept. At one place only he kept cobalt and nickel. In the same slot, in the same column, he kept two elements. And those two elements are not in similarity with the other. If we take cobalt and nickel, they are placed in the same column as that of fluorine, chlorine, and here bromine will be there in his table. Cobalt and nickel were placed. Here two elements are placed. That is one drawback. And that too, they are placed with the dissimilar elements like fluorine, chlorine and bromine. They are completely having dissimilar properties. These are metals, these are non-metals. But he has arranged the elements in the same column. That is his drawback. And here also see arrangement of iron. He arranged iron far away from this cobalt and nickel, which will exhibit the properties similar to one another. Okay. These are the drawbacks of Newland's octaves. What is the first drawback? After calcium, whatever the element you take, every eighth element is not exhibiting the properties similar to that of the first element. That is first drawback. And he kept two elements in a single slot. Two elements, cobalt and nickel, in a single slot. That is one more drawback. Two elements in single slot. That is one drawback. And while arranging in the column, he placed dissimilar elements in the same column. See, cobalt and nickel placed in the column of fluorine, chlorine and bromine. That is drawback again. Dissimilar elements in the same column. And he placed metals which resemble the properties too far away from each other. That is also one more drawback. Okay, he laid the foundation, he contributed. How he contributed? The main point, every eighth element is exhibiting the properties similar to that of the first element. Lithium, sodium, beryllium, magnesium, these are come under modern periodic table only. If you observe, later if you observe, these up to this it is okay. But later on he was unable to explain why it is. And he didn't left any spaces, because after his arrangement, later on some other elements were also discovered. But he has not left any gap in between his arrangement, thinking as if no elements were found later. That is one more drawback. No gaps were left in his periodic arrangement, thinking that no elements were found in future. That is one more drawback. Okay, but he laid some foundation. What is the property he has considered? Increasing atomic masses. This is all about dobereiner triads and newlands octaves, and very important for bits point of view. It will be asked, and if you learn it thoroughly, it is very easy. This is somewhat some part of his classification, newlands octaves classification, and these are the drawbacks of his classification. Later on, to rectify, Mendeleev arranged the elements. He has done extremely hard, good work, we can say, because almost modern periodic table and Mendeleev's have almost have maximum similarity. Okay, that's all for today. If you like the video, please click on the like button and stay tuned to my channel and share it with your friends. If you haven't subscribed, please subscribe to my channel. You will not cost anything if you subscribe. If you subscribe, I will be happy that these many people are there to watch me. That's it. Nothing I will get out of it. Okay, that's all for today. Hope you have enjoyed. Bye bye.